Hey, everybody. Welcome back to another episode of Beyond the Blueprints. My name is Chad Jennings. I'm the head of customer voice and product experience, and I'm joined today by the Shorthills AI team. So we've got PD and Rishikesh. Rishi, introduce yourselves really quickly and your company.
So I'm Paramdeep. You can call me PD. I'm one of the co-founders of Shorthills AI. So we are a tech company that's very focused on generative AI and data engineering solution building. Our core focus is to make sure that we build agents and technology that can really help drive ROI for our customers using data engineering and generative AI practices.
And today we're going to be diving into a solution that Short Hills has created. We won't reveal which industry yet. Get to that in just a sec. And Rishi, please.
Hi everyone, this is Rishikesh. You can call me Rishi. So I look after the marketing and pre-sales team here at Shorters, and I'm leading that team. So I'm looking forward for this conversation. Yeah.
Very good. Now, I know Short Hills operates over several different industries, but we're going to focus on just one of them. So, PD, if you would, can you describe to me the use case that we're going to be discussing today, and the problem that you and your company are trying to solve for your customers?
Sure. See, as an organization, we have been utilizing generative AI and agentic AI for quite some time now. So, in fact, when we started a company about 8 years ago, we started building a product using NLP, which eventually changed into generative AI, and we have built multiple use cases using the same. But today, we will focus on utilizing AI for search. So, generative AI for search. And again, within search, there are two places where we have dealt into details. So primarily legal and healthcare sector. And then today I'll focus a little bit more on the legal side. So how can generative AI be used for legal? Today I'll focus on search, but I'll tell you what else can be done with generative AI within the legal sector.
We had a couple other items that we wanted to talk about the use case. So, it's search. Roughly, it's a RAG architecture that we're going to be describing here. But can you go into a little bit more detail about the use case here?
Primarily, people, you would have seen a lot of RAG demos going around, and I think most of that stuff is being done to showcase the capability. So that means those are like toy implementations. What I'll try to focus today is how do you scale that up. So if you have, let's say, hundreds and thousands of documents, and those documents could then be divided into legal judgments, legal briefs, point of views, acts. How to differentiate between these documents, and even if there are, let's say, a lot of kinds of documents possible, how do you scale search? And I can tell you from my experience that that there is no one single answer called search. It's like a journey, and I'll tell you as in how we went through that journey, where we started in terms of implementing search for our clients, and where we stand right now, as in what possibly we could do.
We're going to talk about keyword search. We're going to talk about vector search, particularly when we get into the architecture. So let's scoot right along to the stuff that preps us to get right into the architecture. Because when we were doing the prep, you described to me that you've got several customers, particularly in legal, that have like on-prem requirements, right? So not everything can get built in the cloud or wholly in the cloud. But can you explain a little bit more about what's driving your clients to mandate this install has to be on-prem or this portion has to be on, can you tell us about some of those dynamics, please?
Sure. See, whenever what I found is that enterprise customers, whenever they're not comfortable sharing their data with a large cloud partner, so for example, if they're not ready to share their data with Azure or AWS, that's when they would typically look at a solution that's on-prem. That has a real value where they want to make sure that whatever the confidential information is that they don't want to share with a large language model, they want to store that in-house. So typically this would be whenever they have data that is PII, that's a personally identifiable information, or PHI information, typically banks, financial institutions, healthcare institutions, and even professional services companies don't want to share that data. They want to make sure that that stays on-prem.
I'll just say that, to be fair, the hyperscalers have all done a lot of work recently to make sure that the data that you bring into their ecosystem, and IBM is the same, right, with our Granite model, where if you bring data into their ecosystem and you put an embedding into their model, that doesn't then go get used to to update their foundation model. So in the very early generations of LLMs, that wasn't the case, but I certainly know several of the hyperscalers have made a big point of developing that. So even beyond that, you're saying that like customers are still not ready to share with the hyperscalers.
Absolutely, absolutely. See, there is if you look at the even the cloud adoption journey, there are still institutions that are lagging behind. So that means there could be a regulatory impact. So a regulator doesn't allow them to take the data even out of their premises. So that's a complete possibility. So then they want a solution that's really in-house. And I think scaling and deploying that solution in-house is a bigger challenge, because obviously large language models are relatively compute hungry. So you want to make sure that when you are deploying them on your premises, you have the right tools and technology, and you are not using a bulldozer where actually a hammer is required. So their deployment and scaling their deployments, for example, tools like VLLM or NVIDIA kits that can actually help you run them efficiently are pretty important.
Give us a quick outline of some of the primary constraints or design principles that you employed to create your system, please.
In case of legal search, what is important to understand is that there are typically hundreds of thousands of documents that you need to look at before you can get something meaningful out. And these documents could again be categorized as judgments, acts, briefs, old judgments, point of views, etc. Right. So you want to make sure that sort of you can handle a large number of documents. So your solution has to be implemented in such a way that it can like scale to a number of documents. A keyword search is not the only thing that's going to work. So you need a keyword search and a vector search and sometimes a graph search to make sure that sort of you can link the documents together. So building that context out where whenever the user is looking for, let's say, a doc ID, you can route your query to a keyword search. Wherever the user has an intention to ask a question, you route it to a vector search. And whenever the user is doing a relatively deeper research, you route it to a graph search. Each has a different cost and a time of getting the query out. So how to build a solution, one that can scale, two, it can sort of route between the three kinds of implementations and get the relevant context for you. Those are the key constraints when you are trying to implement a system that's not really a toy, but for a larger set of documents in the legal domain.
So PD, that was excellent motivation for what those big design principles are. Yeah, please walk us through what you all built.
I would sort of divide this into two pieces, the full pipeline into two pieces. One is a data ingestion pipeline where you are trying to build the relationships, break the documents in such a way that you can look at those documents as you search for those documents. So and sort of this is a bit simplified architecture in terms of how it is implemented, but the important key points to note out here is that as your files are ingested in your data lake, you want to make sure that one, you chunk them properly. So whatever is the important information that stays together. Two, whatever are the aspects you want to find from within the document. So these are typically the entities that you want to get from the document. These could be the judge name, the case, the type of case, the doc IDs, and everything that's basically the entity part from the document or the year of the document or the type of judgment that's there. All those information you need to extract, create the entity relationship diagram so that sort of you can eventually, when you are searching, sort of all of this comes together and gets you the right context. So that's the processing or the ingestion piece.
The final stage of the previous one is like now the document is chunked, broken up, ready for those three different flavors of search that you were talking about.
And this is a bit detailed document in terms of before you get into the storage, as in how it is chunked, how does the full pipeline work. So, for example, in our case, when we got the document, we would chunk that document into smaller pieces. And again, this looks like a simple thing to do, but I can tell you that the better your chunking strategy is, the better results are going to come. Sometimes, if you chunk it based on just the number of characters or the number of words, as in you may be breaking important information and losing the context out. So chunking becomes important. And there, I think, uh, as in chunking it meaningfully becomes very important. So again, in terms of implementation, using a large language model to extract the entities out, creating a list of entities, and then uh, sort of embedding the documents. So that means creating a vector out of these documents and then storing that in the right storage. In this case, we really used the watsonx.data to store the information that on which we could actually implement search is very important. And now this is the detail of how those embeddings were stored. So once we had the entities ready, the chunks ready, we would create the vector database out of that and store that in watsonx.data. Now, important thing to note out here is that sort of if you do not have a scalable product that can actually implement hybrid search for you, that means a combination of both keyword and vector search, and then possibly an implementation that has the right search technology for graph technology as well, your systems are going to be very slow. So that means once you've implemented for a toy, you can still get the results in a meaningful time. But as the document store grows, it becomes very important to choose the right technology that can actually help you scale up. So that means getting the results in meaningful time, because nobody has wants to wait for a long time to get the search results. And this again shows how the query pipeline works. So the first part was ingesting the data in your database. Right. This is the query pipeline. Once the user raises the query, you need to have the right technology that can scale and still be cost effective in terms of how do you search, how does the vector search work, and then how do you sort of re-rank the results. Once you have the results ready, how do you sort of re-rank them to make sure that the user still gets the best result out of the solution. And Rishikesh would walk us through the numbers that we saw in terms of improvement, in terms of what improvements an end users saw once he had the complete solution in place.
Yeah, I think we'll get to those user impact numbers in just a moment here. Um, well, I mean, clearly, like we've been through three different stages of your implementation. I do have a question for you though. What user interface is that person figure on the left hand side of the screen? What are they looking at? Like, are they getting multimodal responses back, or are they looking at a text chat bot?
So it depends. So right now in this use case that I'm showing, it's a human that's searching for information. They can get PDFs, they can get images, or they can get text files. Primarily within the legal sector, it's mostly Word documents, PDFs, and text. But that's the start of the solution. Now, once you have the right search in place, you can write agents that can actually reply to documents as well. So this user at the end of the day could possibly be an AI agent that's searching for information, then building a full response uh, to let's say a query on its own, and then giving it to a human.
So we'll get to extensions of the system right at the end. Hang on to that. Clearly, you've built like a complex system, and you deployed it at customers at scale. Can you tell us and the viewing community here some of the lessons learned by actually doing the work and deploying it?
The first thing I would like to point out is that implementing search on a small scale of documents, a toy document, or let's say creating a small collab, is a very different ballgame as compared to creating a scalable system.
The difference between the proof of concept and the production system.
Absolutely. So the moment you have 5 documents to showcase, or let's say 10 documents to showcase, and the moment you have 10,000 documents to showcase, those are like two different problems altogether. So that's the first thing to keep in mind. The second is that, as I said, there's no single solution called search. Search is a journey, right? So you want to improve, keep improving. And I still feel we keep improving on whatever we are implementing. So as I said, we moved from like a keyword search to a vector search, came back to a keyword search, amalgamated the two to create something called a hybrid search, then implemented a GraphRAG on top of that, found that GraphRAG makes your system very slow, then implemented a lighter version of GraphRAG that made sure that sort of whatever you were getting was in reasonable time and cost. And eventually it all boiled down to implementing a DevOps solution that can actually scale this full solution up. And then choosing the right tools and technologies. So for us, what really worked was choosing the IBM Watson DataX platform that actually helped us scale so many documents that we were trying to search on. So I would say it's a journey, and then choosing the right tools to scale. And then definitely whatever you see in the internet, most of those tools are good to create POCs, but don't scale very well.
Clearly, as you are developing this, right? We're all in new territory here as we're working with Gen AIs, right? It's just not that old a technology, at least not in the public parlance. Your team had to, listen hard to your customers and it had to like modify what they were doing. There's no way you can sit down and like do a big waterfall diagram at the beginning. It's like, okay, this is what we're going to do. Bum. Here are all the milestones. Okay, great. Planning is done. Let's just go execute, right? Or is that how you did it?
Absolutely not. Absolutely not. As it said, it's an iterative process. So your clients keep pushing you to improve the results, and you have to be nimble enough to try out the new technologies, and then make sure that you're still following the basics to make sure that the solution scales well.
Obviously, then like modular architecture is important because you'll swap things out as we go. Those are excellent. I'm sure lots of folks are going to be taking good and copious notes through that portion of the interview here. Rishi, couple questions for you.
Yeah.
Can you give us a little bit of insight as to what the customer impact was, right? You guys did all this work, you deployed it for the customers. Like, how did it go?
Yeah, I think we were able to provide a great value to our client. The search time become faster. The recall in the precision value improved more than 60%. So our solution were able to give references and citations to this search result that were earlier missing in the solution. I think that was a very critical part that we have solved. The other two most important factor that I want to highlight here is that we have improved the comprehensiveness by around 40%. It has increased by 4x, and the diversity of the overall search result has improved by around 90%. So it is improved by 9x. So by these two factors, I think we have made the search result more reliable and more complete. So as I believe what our team has been able to deliver, I think we have provided a very significant value to our client, and we are very proud about it.
Well, congratulations. But for folks that don't understand those terms, I'm going to ask you to define. So, first, you had a 4x increase in comprehensiveness. Can you define what comprehensiveness means in your context, please?
By comprehensiveness, we mean how well the search result have been able to capture all the different aspect and all the details of the question or the query that the user had asked. So for the end user, they would have a more set of documents to look into to form any opinion or judgment that earlier was limited or very less. And by the 9x improvement or the 90% improvement in diversity, we mean that the system is not giving just one type of interpretation or angle. It is giving a broader angle of perspective and varied line of reasoning to make the decisions and the judgment. So both of these they look similar, but I think the differences are in the nuances of the result that the system generates, and both of these make their system more complete and the search result reliable.
So, see, in terms of diversity, what happens typically in the legal sector is that when you are trying to defend your case, you want to you could have different grounds for rebuttal. Now, what a system did was it would find out all those grounds for rebuttal and then give an argument on what can be done. So it's very important within the legal sector just to make sure that you're not just giving one rebuttal. So you could have like a comprehensive answer on one rebuttal. So that's like comprehensiveness. You can say that I have made my point clear. So there could be like say one line of argument. You have like 10 cases within that line of argument. You have stated all those 10 cases. So you haven't missed, let's say, two of those 10 cases. That's comprehensiveness. And then there is a how many lines of argument, or let's say how many grounds for rebuttal do you have? So there could be like 10 grounds for rebuttal. In each ground of rebuttal, you could have, let's say, 5, 6, 8, 10 cases. So have you captured all those nuances within your solution?
That's very helpful. And certainly we've all had experiences where you ask an off the shelf LLM a question and you get a portion of your answer back and you know that it's helpful, but it's not complete. And when you're talking about like either medical, which is another industry we're not going to talk about tonight, or legal, you really don't want to get that 70% answer. So I very much appreciate the improvements you've made in both comprehensiveness and diversity. So clearly you all have done a lot of work. That work has been driven by the requirements that your customers come back. We just talked about those. The tech supporting you is primarily like AWS and watsonx.data, which is terrific. But these things are evolving so fast. Where do you want to take your solution next?
So again, I will give my 2 cents, and then Rishi can add what he feels is the requirement in the market. So I feel that the next wave or the next value is going to be generated by agents. So the legal research is good, but you're still feeding that to a human. There is a possibility that the human can be empowered further. So that means once the legal research is done, you could get an agent to take the next step. So the agent can look at the information and then try to draft a response to the query that you're getting. So that's one possibility.
Right.
The other is
It
agent
takes
could
the
again.
action that it's got authority to actually take. Yep.
Absolutely. It could have multiple tools. It can have a tool to write a document. It can have a tool to write a PDF. It can have a tool to send out the email. So all those processes can be automated. And again, I'm not saying that you should go ahead and automate everything in one go. But but I would still say that feeding this information back into agents can make this much more effective. And then a human, it could be a real co-pilot to human where it researches, drafts the document, a human reviews that document, and then sends it out. I would still not say that you should directly be responding to legal queries automatically using AI agents.
Right, right. Like it's going to be another evolution, right? Like what authority makes sense, what authority isn't proper. However, I do think that we should come back in a few months and see how Short Hills has modified this tool. Gentlemen, thank you so much for joining. Is there anything that you would like to share as we wrap up here?
If you were to ask me a single advice, it would be to choose your tools wisely.
Okay.
So it's we're trying to build something. Do not choose your tools that look shiny or look cheap, but eventually the total cost of ownership increases tremendously. So to choose them wisely. Choose tools that are backed by quality players that can actually help scale to a larger set of documents or to a larger solution, instead of choosing something that can solve a very specific problem, but as the problem becomes larger, you're not able to scale well.
That's a good one. And I very much appreciate that IBM Watson X is part of your stack, given that that's your takeaway. Rishi, close us out.
I would just like to say that we are building some cool AI agents and in-house tools and accelerators in-house. So do look out for us. We'll be building some great solutions with AI and maybe hopefully with IBM Watson X. So great things forward.
Very good, very good. Well, we'll have you gentlemen back in a few months to see how our mutual worlds have developed. With that, everybody, thank you very much for watching to the end. My name is Chad Jennings, and I'm here with Rishi and PD from Shorthills AI, and we'll catch you next time on Beyond the Blueprints. Cheers.